Alright, last one. What do they want to know? How long? That's time. Will it take for a basketball spinning on someone's finger to stop? Angular acceleration of negative, so it's slowing down, 0.15. And initial velocity is 27 radians per second. Alright. I guess I'm going to call this A because they have a part B in there. It's going to be final angular velocity equals initial plus AT. Its final was 0. Its initial is, what did they say, 27 radians per second. Its angular acceleration is negative 0.15. And T is our question mark. So you have to subtract that 27 radians per second from both sides. And that's going to equal my 0.15 radians per second time. I guess the negative should have been in the parentheses, whatever. Doesn't matter. T equals negative 27 radians per second divided by, oh, that's radians per second squared up there. This is a negative here, so I don't get negative time. 0.5 radians per second squared. So 27 divided by 0.15, it's going to take 180 seconds, really? That's a long time. These aren't real numbers. Alright, I'm going to do that second one over here. We need to know how many revolutions. Well, I'm going to go this route first, then we'll convert. And 0.5, so 1/2 AT squared. Remember that back in the day? And my A wasn't 0.15, but it was negative. My time is 180 seconds, which will be squared. So I'm going to find radians, then I'm going to convert to revolution. So my 180 was in there. I'm going to square that, multiply that by 0.15. Multiply that by 0.5. And I get this many. This is radians. Careful, 2430 radians. This whole thing's negative, so it's just a direction indicator of going clockwise. And now I have to, I have to turn 2430 radians into revolutions. One rotation revolution is 2 pi radians, but by radians. So my 2430 divided by 2 pi. And I get 386.7. And that would be rotation / revolutions. Woo woo? Woo woo. Finally done. Bye-bye.